ladies and gentlemen. It's a great pleasure to be here with you today. I'm Tatjana Pljesa from Institute of Virology, Vaccines and Serotyping, Belgrade, from Serbia. Today I will speak about wild world outspread problem regarding pertussis and to present our findings about effects of the inclusion of contemporary B. pertussis strains in the vaccine composition on temporal trends in B. pertussis population. First of all, according to some of the most respected scientists in this area, pertussis or whooping cough has persisted and researched in the face of vaccination and has become one of the most prevalent vaccine-preventable diseases in Western countries with estimated infection frequency of 1 to 9%. Also, Bordetella pertussis poses a threat to infants that have not been completely vaccinated and for whom pertussis is a severe, life-threatening disease. Today, unfortunately, pertussis is still one of the leading causes of vaccine-preventable deaths in the world. According to the assessment of WHO for 2013, there's about 60 million estimated cases in the world and 89,000 of estimated deaths, although vaccine coverage is was at that year about 84%. Most fatal outcomes were in Africa, Eastern Mediterranean, and Southeast Asia. According to the most relevant authors dealing with this problem, resurgence of pertussis has been observed in many countries with long vaccination history. So it occurred in Argentina, Canada, then USA, Australia, Netherlands, then Israel, Spain, Finland, UK. And that's the question, why? Sure, confirmed reasons for this phenomenon are still not fully clear, but it is assumed that there are several possible reasons, like better education and awareness about disease. Then, we have now better diagnostic methods and improved reporting. Also, there's a waning of immunity, of adaptive immunity through the time. Then, adaptation to the vaccine-induced immunity and the fact that the whole cell vaccine induces longer-lasting immunity than acellular one, and the switch from whole cell to acellular vaccines may have aggravated the pertussis problem. Also, antigenic divergence of pertussis toxin and pertactin has been occurred between vaccine and circulating strains in many countries. It has been found that B. pertussis virulence factor show polymorphism. So, nowadays, we have widespread antigenic divergence between circulating isolates and vaccine strains. And those allele changes from vaccine to non-vaccine types has been occurred every 50 to 30 years. Now, let's turn on our attention to polymorphisms of pertussis toxin. Until now, there's 5 types of pertussis toxin subunit A: A1, A2, A4, A5, and A8. In most countries, predominants in isolates are ptxA1 and ptxA2. But on the other side, most vaccines contain ptxA1, ptxA2, and ptxA4. For example, Toxin, widely used acellular vaccine strain, contains ptxA2. Also, regarding polymorphism of pertactin, 13 different pertactin alleles have been found until today. So, there's allele changes from vaccine to non-vaccine types every 50 to 30 years. The most predominant in isolates all around the world are pertactin 1, pertactin 2, which is mainly caused of epidemics, and pertactin 3. At the other side, there's vaccine strains containing pertactin 1, pertactin 7, and pertactin 9. Next, we will take a look at this figure showing the average pertussis incidence in 26 European countries. You can see there are some fluctuations and occasionally rising of incidence, but only in a case when we observe it from perspective of summary data. On next slide, you can see this figure averages is put on the figures of singular incidence in those European countries. And what you can see, there are some countries with much higher incidence than average, like Ireland, Spain, Ireland, Sweden, Norway, Netherlands, Estonia, Slovenia, Slovakia. So today there are two vaccine types in the whole world still. There's a whole cell vaccine, which is made of inactivated whole bacterial cells, and it's produced, different manufacturers use different strains, and mainly isolates from population. It induces both cellular and humoral immune response it's mainly Th1 type and also Th17. At the other side, there's a acellular vaccine containing manufactured and the purified antigens of the cell, like pertussis toxin, or combined with filamentous hemagglutinin, or both of them with pertactin, or all of them with fimbriae 2 and fimbriae 3. They mostly use one strain, Toxin vaccine strain, and introduce humoral immune response, mainly humoral immune response, and mainly Th2 type and Th17. According to the new weekly epidemiological report from 25 July of this year, WHO gave a statement that although local and systematic reactogenicity are more commonly associated with VP-containing vaccines, both AP-containing and WP-containing vaccines have excellent safety records. Here, distinct mechanisms of immunity induced with whole cell and acellular vaccines. So you can see the difference between immune response. Now that we have seen the complexity of problem regarding pertussis resurgence, let's look at some of our findings about pertussis in Serbia, country where the vaccine with unique formulation has been used for more than 50 years, and that provides us opportunity to study possible effect of inclusion of contemporary strains into the vaccine composition. As you can see in this figure, pertussis incidence in the Republic of Serbia from 1965 to 2011. You can see that after introduction of vaccination, which was in late 50s, it's been decreasing with some peaks, and it's very stable until 2000. So, in Serbia, pertussis is notifiable infectious disease. Diagnosis is performed by culture and serology, and for last few years, PCR is also introduced in diagnosis. And there's one fact: incidence in Serbia is still decreasing, although in other European countries is increasing. What about vaccine? Vaccination in Serbia has been used since 1957, and the composition of vaccine have been regularly changes to coincide the strains from population. So the last vaccine composition was changed in 1985, and it contains 4 different vaccine strains, which are different by serotype. The one strain is Fim2, 2 strains are Fim2.3, and 1 strain is Fim2.3. In last 10 years, a cellular vaccine can be administered in private practice too, and in this year, in the immunization calendar, a cellular vaccine is introduced. So, in Serbia, for more than 50 years, vaccine strains have been changed regularly to coincide with isolates circulating in the susceptible population. So, this unique formulation gave us opportunity to study this effect of inclusion of contemporary strains. So, we performed identification of serotypes and genotypes of Pertussis vaccine strains and circulating isolates between 1953 and 2011 and compared them with circulating and vaccine strains in other European countries, USA and Australia. So, clinical isolates were divided into 4 groups. In 4 groups, there were isolates before introduction of vaccination. In the second group, there's isolates just after introduction of vaccines. In third group, there's isolates from period when the 2 new strains were introduced into vaccine composition, and the fourth group were isolates from modern era. We performed serotyping with monoclonal antibodies against Fim2 and Fim3 by slide agglutination tests, and also genotyping using life cycle PCR and pulsed field electrophoresis of Pertussis toxin subunit and also pertactin. Also, we investigate ptxA profiles. So, what we found? Regarding analysis of vaccine strains, we found that 2 strains, strains 1772 and strains 2047, which was old strains isolated in 1957 and added in vaccines, one in 72 and another in 68, were pertactin 1 type and pertussis toxin A2. At the other side, the strains that are added in vaccine in 1985, one strain has pertactin 1 and pertussis toxin A1, and what's most interesting, one strain, strain 8, has pertussis toxin A1, but very unusual pertactin 2. So, what about isolates? At the other side, serotyping of Pertussis isolates show that in the pre-vaccine, in the era pre-vaccine, the most prevalent was serotype Fim2.3 and also Fim2. But after introduction of vaccine, serotype had been changed, and they are mostly Fim2.3, but also they were not Fim2 and Fim3 became dominant. After that, in the 80s, Fim2 again was in population, and that's the era when the 2 new strains have been input into the vaccine composition. And after that, in the modern era, we have all 3 serotypes circulating. Regarding genotyping of pertussis toxin subunit A, in the era before vaccination, all isolates were ptxA2. After introduction of vaccines, there are several ptxA1 isolates, and after that, they became most predominant in the 80s when the 2 new strains were introduced into the vaccine composition, and they also stay prevalent in the modern era. So, pertactin genotyping's results suggest that in the first 2 periods, all isolates were pertactin 1. After that, in the 80s, there are some other of pertactin types, like pertactin 2, pertactin 3, and pertactin 11, which was very rare in other countries. So, in modern era, we have all 4 pertactin genotypes, but pertactin 2 serotype is still rare when it is compared with other European countries. This is the table. We can see the changes through the time. So, before we go to the next, let me briefly restate. In Serbia, vaccine strains have pertactin 1 and pertactin 2, and also ptxA1 and ptxA2. Although in the rest of the Europe, the vaccines that they are using are mainly pertactin 1 or pertactin 7 and ptxA2 or ptxA4. Therefore, in circulating strains in Serbia, the most predominant are pertactin 1 and pertactin 11, and also ptxA1. Although in Europe, the most prevalent is pertactin 2 and pertactin 3 and ptxA1. Results of pulse field gel electrophoresis show the vaccine strain in Serbia shows 4 different PFG profiles. Regarding clinical isolates, there were 22 different PFG profiles found. But what's more interesting is that 43% of them had unique Serbian profiles, BPSBR, which are not being found in any other countries until now. So, there's changes in PFG profiles was observed over time. And among 5 common profiles, 2/3 of isolates were among them. There were BPSR23, BPFIN-R1, BPFIN-R9, BPSBR6, and BPSBR5. All PFG profiles observed in the 50s disappeared since then, except BPSR23. So this profile was found in all the study periods. And 95 of those isolates belonged to the 2 clusters having a high similarity with a minimum of 78% overall relatedness. So now we can sum up the difference between findings in Serbia and other countries. Well, although in Serbia, vaccine strains had all 3 serotypes, and after the introduction of vaccination, the frequency of serotypes Fim2.3 decreased. Fim2 has become the most prevalent serotype during the study period. At the other side, in most other countries, Fim2 predominated in unvaccinated population and was displaced by Fim3 strains when vaccination is introduced. Also, regarding pertactin genotyping, 3 vaccine strains were pertactin 1 and 1 strain was pertactin 2. Isolates were mostly pertactin 1, pertactin 2, and pertactin 11, but frequency of pertactin 2 genotype was very low and appearances were late compared to other countries, and the most dominant were pertactin 1 and pertactin 11. At the other side, the pertactin 2 is by far the most prevalent type in modern isolates, and pertactin 11, which is very common in Serbia, is found only in Australia and China in the 1980s. The low frequency of pertactin 2 strains and their relatively late emergence in Serbia may be due to the fact that the vaccine contains an isolate having pertactin 2 allele was introduced in vaccine composition in 1985. So, regarding pertussis toxin genotyping, 2 vaccine strains harbor ptxA2 and 2 strains harbored ptxA1. There's a shift from ptxA2 to ptxA1 has been observed in isolates since the 1960s. But ptxA1 was predominant again in 80s, and reappearance of isolates containing ptxA2 were noticed after the 2 new strains harboring ptxA1 were added into the vaccine in 1985. So, the high frequency of strains harboring ptxA2 in the period of 1999 to 2011 was not comparable to that noticed in many other countries. Regarding PFG analysis, we found a specific population of circulating B. pertussis strains in Serbia, and the profile BPSR23 representing 30% of isolates studied persistent in the whole study period. Only one strain isolated in 2000 was BPSR11, and 33% of isolates studied showed unique BP-SBR profiles. So, BPSR23 was prevalent in Finland and Sweden in the 1970s, but not after 1990s. Also, BPSR11 was found to be predominant in 6 of the 8 European countries. According to the observed findings, the B. pertussis population in Serbia is different from other vaccinated population. And this difference may be related to the vaccine composition that had formulation of inclusion of contemporary strains from population. Furthermore, this observation was in compliance with findings of, for example, King and collaborators, who said that variation in pertactin affects vaccine efficacy in the mouse model, and also with findings of Botero and collaborations that the adequate bacterial elimination rates were observed in mice immunized and challenged with the same vaccine type strain. Also, with findings with Pereira that said the vaccine prepared for the recent isolates provided the highest mouse protection when compared to those prepared from the old isolate as Tohama. So, when we know that increasing evidence that the currently available acellular pertussis vaccine are not providing optimal control of pertussis in the United States and many other countries, and this has stimulated interest in improving of the current vaccines and in the development of new ones. So also Mayday and collaboration said that a better understanding of the limitation in the current vaccines and the basis for the pertussis resurgence is needed to design improved vaccines. However, one of the options for deep improvement can be modifications of antigens in current vaccines, like possible modifications of current vaccines while maintaining the same antigenic composition, including changing of the individual antigens to match antigens of currently circulating strains of Bordetella pertussis. Thank you for attention. I would like to also thank Professor Choi Shi-hye from the Pertussis Reference Laboratory National Institute for Health and Welfare, Turku, Finland, with this investigation.
So I'd kind of like to ask if questions could be directed at during lunch so that we can be on time, or
the strain which you have suggested to change for the vaccine production, this is only applicable for acellular pertussis or for whole cell also?
We know that it can be done with the whole cell, but I think it could be also with a cellular one. Okay. The changing of strains, like for performing some other vaccines when the strains are followed through the year, like influenza. And in pertussis, it's not a yearly basis, but it have to be changed for 50 to 30 years or according to the epidemiological situation.
Okay, thank you.
So we'll move on to the next talk, and please chat during lunch. We will.
Okay.